It's time for some violence in the atmosphere. Violent weather really equates to these things. Unstable air, we know what that is. It's a parcel of air that's warmer than the surrounding atmosphere and wants to rise. Cumulonimbus clouds, we know what those are, those big clouds. Hail, we know what that is too. Now we're going to meet some new guys. Squall lines, thunderstorms, lightning, thunder, and tornadoes. All of these things are violent weather. When you have one, you usually have more than one. Sometimes you get them all. Squall lines come first. A squall line is a line of cumulonimbus clouds and thunderstorms that forms in advance of an intense cold front. This is a common event in the spring in the plains states and the Midwest of the United States. What happens is cold air, generally cold, dry air from Canada, comes down into the center part of the United States and it interacts with warm, generally very wet air from the Gulf of Mexico. So that would be like a CP air mass interacting with an MT air mass. There they are, CP and MT air masses. When these two air masses run into each other, that cold air forces the warm, wet air to rise rapidly, creating instability in the atmosphere. Let's look at the left-hand side first. Take a look at that top photo. Just look at the photo first. Take a look, examine it. Look at that. Can you tell what's happening? Excitement is what's happening. The intensity of precipitation is gauged by color. The closer to red, the greater the intensity. Notice the line of red. That's because to the left is a cold front moving towards the right where there's warmer air. That forces all that warm, wet air to rise rapidly, creating intense precipitation. That's a squall line. These things can be hundreds of miles long and they are highly unstable. Now look to the right and you can see a squall line moving in. It's a long line of cumulonimbus clouds. Any single cumulonimbus cloud can produce lightning, thunder, hail, tornadoes. Well, if you have one, there's a possibility. If you have 200 of them, the chances go way up. And that's what squall lines are. That it's an area of very unstable air and high likelihoods of violent weather. Thunderstorms are formed in cumulonimbus clouds. They include lightning and thunder. You do not get thunder without lightning. You have to have lightning to have thunder. Lightning is just an intense discharge of electricity. It's a little bit like when you rub your feet on the carpet and go touch the doorknob and get an electrical shock. It's a very similar thing, only obviously significantly more electricity is involved in lightning. Thunder is the result of the superheating of the atmosphere from lightning, as we'll see. Take a look at this diagram on the right-hand side. Notice the updrafts and the downdrafts and their proximities to each other. On the right-hand side, you can see that there are warm updrafts of air. That's very unstable air rising. On the left-hand side, you see where it says cool downdraft. That cool downdraft is largely the result of heavy precipitation. It's called the rain shaft. Rain falling in gobs down to the ground, which pulls air in towards the ground. So you have very violent updrafts and very violent downdrafts within that cloud. That creates friction. That friction then generates ions in the atmosphere. An ion is simply an electrically charged atom. Here's about 10 cents worth of chemistry. An atom has two basic parts. The nucleus, which has two parts itself, protons and neutrons, and then surrounding the nucleus is the electron cloud, which has electrons. Protons have positive charges, neutrons have no charge. They're the same number of protons as there are neutrons in the nucleus. Electrons have a negative charge. The way you give an atom an electrical charge, in other words, turn it into an ion, is by either adding or subtracting electrons. If you add one extra electron, because electrons have a negative charge, the entire atom takes on a negative charge. If you subtract one electron, there's now one more proton than there are electrons, and the result of that is that the entire atom takes on a positive charge. That can happen through friction in the cloud. If you look at this diagram, notice the separation of positive and negative ions. Okay, atoms don't want to be that way. They want to be neutralized. Now, if there's only one positive and one negative, this is going to do nothing. But when you start separating gazillions of these things, they're highly unstable and they want to stabilize. Lightning is going to be the result of them stabilizing. In other words, the positives and the negatives will run at each other, slam into each other, and when they do, that's lightning. Thunder is the result of a lightning bolt, because a lightning bolt, although most of them are not any more than about an inch in diameter, nevertheless, not only do they carry a strong electrical current, they can be as much as 54,000 degrees Fahrenheit. Now, they may only last for 1/10,000th of a second, but nevertheless, for that very brief amount of time, the air that's in contact with that lightning bolt can be superheated. That causes it to expand, and that expansion is what we experience as thunder. Tornadoes are intense low-pressure systems that can have wind speeds up to 300 miles an hour. 300 miles an hour is pretty fast. It's not 1,000, but it's pretty fast. If a pencil comes at you at 300 miles an hour, it's going through you. So you can imagine that when a tornado goes over the top of a house and obliterates that house, now you have wood and nails and metal and electrical cords and bricks and everything else flying in the air. If that's going 100, 200, 300 miles an hour and it hits you, it's not going to be good. Notice the confluence of atmospheric influences in the center of the United States. This is the Plain States in the upper Midwest. It is the classic zone of contention on Earth. And it's flat as a board. Remember, our mountain ranges do not run east-west, they run north-south. That allows cold, dry air to come down out of Canada and warm, wet air to come up out of the Gulf and meet. You can see in the middle of the country, we have what's known as Tornado Alley, stretching from Texas up to Minnesota and South Dakota. It's the most tornadic area on Earth because of the warm, wet air and the cold, dry air slamming into each other there. If you take a look at this, this is essentially how a tornado forms. Notice in A on the upper left-hand side, you have two blasts of wind indicated by the blue arrows going by. Now notice the wind that's blowing along the surface of the planet is slower than the wind that's blowing at, let's say, 1,000 feet above the ground. This is because of friction. The air that's blowing along the ground is encountering friction with the ground, trees, houses, whatever's there, and that slows it down. Whereas the air that's blowing at 1,000 feet above the ground doesn't have the same kind of friction, and it's able to move faster. And so what happens is a little bit like this. If you took your left hand and flattened it out with your palm facing the ceiling and put a pencil in your left hand. Go ahead and do that. I'll wait. This is a long video anyway. What's the difference? Good. So you set the pencil in your hand and it's going across your fingers. Now you take your right hand and put your right hand so that it's equal with your left hand, palm to palm. Now take your right hand and move it towards the tips of the fingers on your left hand. What's going to happen with the pencil? It's going to roll. This is what begins to happen in the atmosphere. That because the winds are going at different speeds, it sets up a roll within the atmosphere. So the air is kind of spinning. But you can see that it's parallel to the ground. It's horizontal. However, in B, now what happens is this. Because of highly unstable air wants to rise. That rising unstable air causes that spinning tube of air to be tilted vertical to the ground. So at a 90-degree angle or something like that. Then if you look at C, you can see at C that when you put this thing into A cumulonimbus cloud, which already has very rapidly rising air, and now you have this spinning tube, this is how you can begin to create a tornado. Many times when you see a cumulonimbus cloud that's going to produce a tornado, the cloud itself begins to rotate prior to the tornado coming down.